Hi guys, so a quick lesson on exponential functions. The first exponential function that you would have came across was probably the compound interest formula, where the period was the indices, so that was what was changed. So if you put your investment into a bank for 3 or 4 years, or if you put it in for 6 years or 12 years, it was the indice that changed. Okay, so that was the first time you actually encountered probably exponential functions. So when we're talking about exponential functions, we're actually talking about the general form of a simple exponential function is f of x is equal to a times a to the power of x. So the capital A, and then the base is the small a to the power of x, where a and a are constants. A must be greater than 0, and a does not equal to 1. Okay, so a does not equal to 1. Sorry, let me try that again. A does not equal to 1. And the exponent must be a variable. So that's really, really important. When your exponent is a variable, that's what you're talking about for exponential functions. Okay? An exponential function is given by f of x is equal to 12 times 3 to the power of x. So just really quickly, am I sure that this is an exponential function? I am, because if I look at my variable, it's the indice. Okay, so the indice is a variable, so therefore I'm dealing with exponential functions. So if I try and work these out now, calculate the value of f of 0, so when x has been replaced with 0, so I'm going to write out my f of 0 is equal to 12 times 3 to the power of 0, and we know that anything to the power of 0 is equal to 1, so 12 times 1, which is equal to 12. Okay, can do the same for the next one, f of 2. So again, I'm replacing my x with my 2, so it's 12 times 3 to the 2. And 3 to the 2 we know is 9, and 12 times 9 is 108. So for the last one then, I'm getting a power, but it's a negative power this time. So f of negative 2, which is equal to 12 times 3, replace my x with negative 2, so it's 3 to the power of negative 2, which is equal to 12 times, so when I have a negative indices, I change it into a fraction, so it's 1 over 3 squared, which is equal to 12 times 1/9, and I end up with 4 over 3, because I get 12 over 9, which then becomes 4 over 3 when simplified. Okay, so pretty easy stuff. Just plug in what your new x value is and work out your questions. Okay, but again, to know how to pick out an exponential function, it has to have an x variable as the indice, or a variable, sorry, it doesn't have to be x, a variable as the indice or exponent. Just looking at this example here, so we're going to apply a couple of the skills that we've already been practicing. So 3 to the power of 2x minus 5 times 3 to the power of 5 minus 3x. So the first thing you should notice is that they've got the same base. So 3 is the base, so I'm going to just, when I'm multiplying with the same base, I know that I add the powers. So it's going to be 3 to the power of 2x minus 5 plus 5 minus 3x. So I'm adding the powers. I'm going to put brackets around it because I find a lot of people make mistakes with negative signs, so be careful, okay? So it's equal to 2x minus 5 plus 5 minus 3x. So I end up with 3 and 2x. So again, I'm collecting my like terms. It's like solving this or simplifying this expression. And the like terms are the constants, which are just the numbers, the negative 5 and the plus 5, and then the x variable, so 2x take 3x. So 2x take 3x is negative x, and my negative 5 plus my 5 is 0, so it's just negative x. Okay, and that's it, we're done. So that's basically what we're going to be looking at for exponential functions, and the next time we'll move on to exponential graphs and what they look like. Okay.